you were supposed to complete the warm-up. We have a table showing the relationship between the base length B and the area A of some parallelograms. All the parallelograms have the same height. Complete the table. So first, we are completing the table. Table 5. What needs to go here where my mouse is? Okay, class, do we agree with that? Okay, those of you that don't agree, what do you think needs to go there? Instead? Okay, and why? Okay, so 4.5 times 3 is 13.5. You were not given like an equation to go along with this table of values. So when that happens, you have to look for patterns. So you can look for patterns within the column. You can look patterns within the rows. What do we notice in this B column? Is there a consistent pattern? It like starts out that way, and then it increases by 1.5 instead of 1. So when they are going up by the same amount consistently, then like you can keep this pattern going. So like if this was 4, I would definitely agree that this would have to be 12 then. But they made it 4.5 instead. So now you're having to look elsewhere to see what the pattern is. And it sounds like some of our classmates noticed that if I go like from here to here, what can I do to the 1 to get 3? Multiply by 3. See if that's consistent throughout. Is 2 times 3 6? 3 times 3 9? So then that's how we can make it a pattern by looking at what could be done to B to get A. So it will be 13.5 there if you want to make that adjustment. We're kind of trying to trick you, so we're going to that. But you can only keep this pattern going if this pattern keeps going up by the same amount as well. Okay. So table 6 then, what needs to go here where my mouse is? 16.5. Anyone disagree with that? What math did we do for that one? 11 over 2 times 3. And you'll even do a few things. You can make this a decimal if that's easier for you. I would say only do that if it's a decimal that ends, not one that goes on forever. But you could also put this in your calculator. My recommendation though would be any fractions you put in your calculator, put them in parentheses so that the calculator reads it right. This one's actually not too bad to do by hand though. Let's just multiply straight across. What's 11 times 3? 33. What is 2 times 1? And what is 33 divided by 2? 16.5 is how we're getting that. So if you just left it as 33 over 2, great, that is a simplified fraction. But let's keep it consistent with the decimal. Yes? 11 divided by 2 times 3? Yes. But 11 divided by 2 times 3 will give you the same. All right. Now, table 7. When we're working in the reverse, what needs to go here where my mouse is?
Well,
And what math did you do to get that?
divided 36 by 3.
So class, does that sound like a good strategy? So if we had to multiply this column by 3 to get this one, then when we're working in the reverse, what's opposite of multiplying by 3? So that is a good strategy. And then you can check, does it work the other way too? Yeah, it does. So table 8, last one in the table, what does it have to be? 15.5. So let me check that if we're doing that same strategy. Take 46.5 divided by 3, and that is 15.5. So this table of values is following a consistent pattern. Okay, questions on that? Alright, so then table 9 for this first set. You had to decide whether each equation could represent the relationship between B and A. So do you think B equals 3A or B equals A over 3 is better? Let table 9 do it. B equals A over 3. So if that's true, then I should be able to plug in my A values and get B for this. And you could also plug in your B values too. So if I'm plugging that in to check, B is 1, A is 3, class is 3 divided by 3, 1. Is 6 divided by 3, 2. So yes, that one's better than this one. We're not multiplying 3 by the A value to get B. That's not what we're doing. So then table 1, between these two options, which one is better, A equals 3B or A equals B over 3? A equals 3 times B. If that is true, then I should be able to plug in these values and it makes sense. So if I plug in A, like the first one, it's 3. If I plug in the first B, it's 1. Class is 3 times 1, 3. And then if you check the others, those work as well. So good practice, completing a table of values by following the patterns. If that is still hard for you, it will get easier. Like pretty soon we'll tell you specific patterns to watch out for. And then you can look for that instead of just like wildly guessing what the pattern is. But the big thing today is which variable to solve for. So let me pull up the learning targets. What we want to be able to do today, and we kind of talked about it in the previous 2 lessons, like I wanted you to start seeing it because it is a hard concept for 9th graders. And it's rearranging equations to pin down a certain quantity and solving an equation for one of the variables. These 2 things are really saying the same thing, just in different ways. So when it was A equals, remind me, was it 3B? And then B was A over 3? So these 2 are solving for different things. Like what was the A representing in our warm-up? Reread it if you need to. A is for, so that's what it's measured in. But A is for the percentage area of some parallelograms. So if I want to find the area of some parallelograms, all I have to do is do 3 times B, which what was B representing? The base length. So this one is pinned down to find the area easier. This one's pinned down to find the base length easier. This is technically easier because all I have to do is one calculation in my calculator versus like isolating and figuring out what A is over here. Okay, times B on each side and then simplifying. This is what we call like easier. Rearranging equations is a skill you need to have. So be able to write an equation to describe a situation that involves multiple quantities whose values are not known. So meaning like multiple variables involved. And know how solving for a variable can be used to quickly calculate values for that equation. I'm recording right now, do this every day. For some reason, like always in March or something, someone will realize, oh, hey, like you record all your lessons? Yes, I could every day. Look at this. I also remind you that you have a practice for pretty much every lesson. And this is a combo lesson, so it's 8 and 9 put together and picking the important parts, we're basically over the same thing. But know that like, yeah, there are 2 separate puzzle pieces, because before we used to teach them separately, but they're only 9 questions total. So nothing crazy, totally doable, you can do it at home, I have faith in you. And it's your check for understanding. So do it, don't do it, you know how much the unit tests are worth, so make sure you do well on those unit tests. These are great practice for it. You do have a quiz tomorrow, so just know like however far we get in the lesson tomorrow, we'll stop and take the quiz in the last 30 minutes. Quizzes, like, you know, don't drastically affect your grade, so do your best, use your notes, use it as practice for the test. Obviously on the test, you can't use your notes, but it's just a checkpoint. You can see how you did the day after. And if you want to correct, you can correct at home. Yeah, so that's pretty much it. Any questions on those general announcements? Okay, so then back to the lesson. We have a real world situation that you really could run into. So like you might be on National Honor Society, you might be in Key Club, you might be on a sport that does something like this. So use your critical thinking to go. I promise I'm not trying to like make you calculate something really hard. Just read it, try to understand what's going on. So after a parade, a group of volunteers is helping to pick up trash along a 2-mile stretch of road. The group decides to divide the length of the road so that each volunteer is responsible for cleaning up equal length sections. Find the length of a road section for each volunteer if there are the following numbers of volunteers. Completely doable math, I have faith in you. For the writing equation part, so first you're doing some math, figuring out these answers, using your problem solving skills. For writing the equation, pay attention to the math that you're doing. See what's staying the same each time, that will probably be in your equation. If it's staying the same, it'll probably be a number. If it's changing each time or varying each time, then you'll probably use a variable. And they're saying use L for length of road section in miles for each volunteer and N for volunteers. You can do it, I think. And then for this one, same situation. Now we're giving you the length that each volunteer would have to clean, and you have to tell me how many volunteers that would be. And then write that equation. So kind of a big task. You do have other people in your group that you can talk about it with. I'll give you 4 minutes. Again, use your problem solving critical thinking. If I have a 2-mile stretch of road that I want to split evenly among the volunteers, how much would each volunteer have to clean if there was 8? Figure it out. It's not 10 minutes already. Figure it out now in front of us then. So everyone else be quiet. What math is implied to do when I need to split something up evenly? Okay. Well, does that make sense? If I have a 2-mile stretch of road to clean up and I have 8 volunteers, would they each clean up 4 miles? So then it's probably not gonna be 8 divided by 2. So always see if your answers make sense. If I only had 2 miles of road to clean, then splitting it up evenly would not result in everyone cleaning 4 miles each, right? So whatever answer I get should be smaller than what? Okay. Wait. Okay, good. So if there's 8 volunteers, they're each cleaning 0.25 of a mile. The math that we did was 2 divided by 8. Right, because we're splitting 2 evenly between 8. Table 3, what about when there's 10 volunteers? How much will each volunteer have to clean up? 0.02. What math are you doing for that? Okay, that is true. I'm not getting 0.02, I'm actually getting 0.2. Okay, that makes sense. But yes, we're doing 2 divided by 10 to get that one. Table 4, what about when there's 25 volunteers?
Us?
Yeah.
Oh, 0.08.
Okay, class, can we confirm, is that it? What math would we need to do for this one?
2 by 25.
Right, so if you guys could all have a way to calculate. 2 divided by 25 is 0.08. Now, table 5, what about when there's 36 volunteers? How much does each person have to clean up? Zero point zero? Okay, and then it is a decimal that goes on forever, so let's just round at some point and then say what's around to. So about 0.056 of a mile. And class, what math did we do for that one? Guys, stop with the side conversation. No. I'm talking to one group at a time and you're all listening to our conversation. What math did I do for that one? Okay, be more specific. 2 divided by 36. Thank you. Reason why I'm showing that is because anytime, and the curriculum does this a lot, anytime it has you solving like a series of math problems, you need to, and then making an equation at the end like this one, you need to look at what is staying consistent each time. So what is staying consistent each time? So it's 2 over a number. That is the same each time. So guess what? In my equation that I'm making, I'm gonna make sure I have 2 divided by something. Is that something that we're dividing by staying the same? No, it's varying each time. So what should we use for things that vary? A variable, and they did tell you what variable they want you to use. What were we dividing by? Like, what was this 10 representing? So what letter do they want us to use for volunteers? So I'll have 2 over n. The equations should have equal signs. So when we were calculating it, what was it telling me? The length in miles that each person would have to clean up. What letter do they want you to use for that? So this is my equation. For some reason, like people seem to get this pretty easily. But then when it comes to making an equation, it's like they choke up and they're like, no, that's hard. Okay, it's actually not. Just see what's staying consistent each time. That should be a number in your equation. Anything that varies or anything that's an unknown are variables. Okay, questions on that? This helps me easily find the length that each person has to clean up. Now, the other part you had to do, and I did give you time, you may or may not have done it yet, but I'm sure you could figure it out if you're called on. You had to now take the length that each person would have to clean up and tell me if that's how much each person has to clean up, how many volunteers were there. So that's what I'm gonna ask you next. I forgot what table I left off on. Okay, table 6. If each person has to clean 0.4 of a mile, how many volunteers were there? So same situation, we're still cleaning up 2 miles of road, but if I figure that each person has to clean up 0.4 of a mile, how many people were there? 5. And how did you come to that conclusion? You did 2 divided by 0.4? All right, class, does that sound like a good answer? If I did the reverse, like what we did earlier, given the volunteers, if I do 2 divided by 5, do I get 0.4? Yeah, so that sounds pretty good. Earlier in my first hour, they told me that they just did guess and check. Which works, right? I mean, if we figured that for 8 volunteers, they're each cleaning up 0.25 of a mile, that's pretty close to 0.4. Like you can pick numbers in your 8 and probably guess and check it. But yeah, that's the math that they're doing. Table 7, if each person has to clean up 2/7 of a mile, how many volunteers were there? Maybe pay attention to how your classmates did it. Problem solve it yourself. If each person ends up cleaning 2/7 of a mile, how many people were there? Alright, that's one you guys have, so I'll come back to you. Table 8, if each person is cleaning up 0.125 of a mile, how many volunteers were there? 16. And what math did you do for that one? All right, let me just check that in my calculator, so I don't have to split the screen. And yes, I'm also giving 16 for that. And then if we did what we know is true, the 2 divided by 16, we are getting 0.125, so that is working. Table 9, for 6/45 of a mile, how many volunteers would there have had to be?
I think it's 15.
And how did you come to that conclusion?
I divided 2 by 6/45.
So dividing 2 by 6/45, which as you can see, looks kind of ugly. You either need to know your fraction rules, or you just need to know how to use the calculator. And like I mentioned before, if you are putting fractions in the calculator, put it in parentheses, and the calculator will get it right. Just do that. But I'm gonna pull up Desmos now. Because again, I don't expect you to necessarily, like, you don't have to know all your fraction rules to be successful, you just have to know how to use it. And that's what I'm doing. All right, so when I do that, I do get 15, that does make sense, right? I can't have a decimal of a volunteer, can I? So that looks good. Table 7. When there's 2/7 of a mile that each one has to clean, how many volunteers were there?
If it's 7 volunteers.
All right, class, what do you think? Does that sound good? Okay, so if we're doing the same thing we did earlier, 2 divided by 2/7. I know my fraction rule, so I know that dividing by a fraction is the same as multiplying by the reciprocal. 2 times 7 is 14, 14 divided by 2 is 7, so that works, good. Now, notice the math that we did this time. Ignore the one from the bell word. What stayed the same each time? So still 2 divided by. This time, what? And then what we were dividing by kept changing, so we should probably use a variable. Am I gonna use n again for that? No, because what was I dividing by? Like, what was it representing? Like, the length that you had to clean up. So I'm gonna divide it by what letter actually? And it's gonna give me what? So this is my equation that helps me find my number of volunteers. That's an easy calculation to do. There's just one thing I need to type into my calculator versus plugging into this one and doing multiple steps to isolate. So, for example, if I was given the 0.4 of a mile and I was just going off of this one, I have to know where to plug in that 0.4. And then I have to isolate n. Which, when it's in the denominator, that can be hard for some people. How do you make any fraction not a fraction anymore? No. So like this one, when we had this as a fraction, to make it not a fraction anymore, I multiplied by the. Okay, you guys are mixing things up now. By the denominator. Any fraction that you don't want to be a fraction anymore, if you multiply by the denominator, then it's not gonna be a fraction anymore. But whatever you do to one side, you do to the other side. That's what I'm trying to do for this one. So then that makes my right hand side 2. My left hand side is 0.4 times n. What's opposite of multiplying 0.4? And whatever I do on one side. That would still give me the fact that I need 5 volunteers. 2 divided by 0.4 is 5. But wasn't it easier just to do 2 divided by 0.4 to begin with? So that's kind of what this lesson is trying to show you. While you could, this is what I did in high school, because I didn't really understand rearranging equations. I would just plug in and solve. But if you just rearranged it to have it equal to n from the beginning, then you're only plugging one thing into your calculator instead of going through all those steps. So pay attention to this, maybe draw it out like how I'm drawing it out to show you. People seem to understand isolating when there's numbers, but when there's letters, I don't know, they seem to like do this. If I wanted to get the n by itself, first I need to break up this fraction, so I need to multiply by the denominator on each side. I get n times L equals 2. If I want the n by itself, undo what's being done, what's opposite of multiplying by L,
Dividing by.
and then do the same on each side. So now the n is isolated. And now I have an equation that can help me find n, my number of volunteers. So at the end of the day, we want you to get the right answer, but you will be assessed on rearranging equations. You will, like that's like a non-negotiable. So I think we briefly introduced it to you with this activity. I think we just need now a lot more examples. and I don't really love the examples of that. So I do have a Kahoot prepared, that'll be kind of like your exit ticket. We'll do, the top three can pick a prize from then. And for the Kahoot, like, I'm not forcing you to take notes. But you do have room on the back, like in some of the margins, we're not doing these activities, I don't like them enough. I think we just need direct practice of rearranging. Okay, so in this one, you're solving for T, so rearrange it to solve for T. I'm gonna freeze it so I can play around with the zoom, but just know you only have 18 seconds. Okay, 2 seconds, sorry. All right, so for this, whenever we say solve for a specific variable, what do we want you to do? Make that variable alone on one side of the equal sign. So yes, kind of like a total, the total is usually alone on one side. Are you guys listening? This isn't for me. Really hard skill for clearly a lot of you. Only 4 of you got it right. Not mad at me, except yes. So when we say solve for T, we want T to be alone on one side of the equal sign. You do that just like you would if they were numbers instead of letters. See what's being done to the T, what's being done to the T. And what's opposite of multiplying by R? Whatever you do on one side of the equal sign. And notice, like, you're not gonna get, oh, T is this number when there's multiple variables. You're just gonna rewrite it. So it ends up being that D divided by R is equal to T. Good, questions? Alright, so let's learn from our mistakes, let's make that accuracy higher. And then the next one. We're solving for S squared this time. Ignore like that it's in parentheses over here, like that's just telling you what to solve for. So we are solving for S squared. Okay, so better accuracy. When they're saying to solve for S squared, what do we want that S squared to be? Alone on one side of the equal sign. So everything else around the S squared needs to go away. And you do that by canceling it out. So see what's being done to it. What's being done to it? Being multiplied by 3. What's opposite of multiplying by 3? Whatever you do on one side. Notice these are not like terms. You can't combine them. All you can do is rewrite them. You're just rearranging it. And order does matter in division. So Yeah, has to be V over 2. All right, next one. So solve for A. B equals A plus B, solving for A.
I actually.
Oh, yeah.
50 points. That's why I'm doing.
So this time we want what to be isolated? The A, how do you cancel what's next to it? And whatever you do on one side. These are not like terms, they're not the same variable, so all you can do is rewrite them. And now A is alone, so that's why this is the answer. Good, getting better. I think the next one is a 2-step, which is more like how you'll be tested, so. Do the same thing you would do as if it were numbers.
I'm the one.
So solve for Z.
Yeah, they. Send this. You want to come down there now and take on some.
Nobody else.